So I'll review one other question using a table of values to graph a log function. In this example, we asked to graph y is equal to log 5 to the power of x. And then to identify the intercepts, the equation of the asymptotes, the domain, and the range of the function. Just a reminder, when we don't have base 10, we can use the equation when we don't have a common power of base 10, then we can use this principle log b to the power n is equal to n. So we'll use that principle to graph. Now, here I selected 1/5, 1, 5, 25, 125. Notice there are multiples of 5 because my base here is 5. So I'll use that. And for the x values, I want it to be, so I can change it using base 5 as a power of that base 5. So that's the reason for selecting 1/5, 125, it's because they are multiples of 5, or I could change it into base 5. So this could be written as 5 to the negative 1. Now this could be written as 5 to the power of 0 is equal to 1. 5 to the power of 1. Oops, probably can't see that. Put it here. This could be 5 to the power of 2, 5 to the power of 3. So now I'm using this principle here. So we have log 5 to the negative 1. So that will give me, the rate is my y. It will give me negative 1 as my y value. Then I have log 5. I'll get rid of 5 to the power of 0. Now, 5 to the power of 0 is equal to 1. So the 0, right? So we can change that. So this becomes 0. 5 to the power of 0 is 1. Then we have log 5 of 5 to the power of 1 is 1. And log 5 to the power of 5 squared is 2. And log 5 to the power of 3 is 3. So anytime you're given a log, look at the base and find if it's a multiples of, and then your x value will be a multiples of that 5 as your base. An example would be if I were to have another example here. So here, what I did was to find values that I could write as a power of 2. So 4 could be written as a power of 2. It's a 2 to the power of 2, same as this one here. So what I've done here is to write values that are going to be written, can be written as a power of 5. So I know 1/5 could be written as 5 as a power of 5, 5 to the negative 1, etc. Now I'll graph my points here, my coordinates. So I have x is 1/5 about here, x is negative 1, x is 1, y is 0. This would be 2 here. X is 5 and y is 1. X is 25, y is 2, which is way here. Now I have my last one, oops, if I have here, my last one here is 125, which is way off my scale. So I'll use what I have. So this graph is going down. So this is log 5 and ask you the intercepts. So number 1, there's no y-intercept, but there's an x-intercept of, for example, at x-intercept at 1. So here we have x-intercept here. There's no y-intercept, so therefore we have an asymptote where x is equal to 0. So this is our asymptote here. The y-axis doesn't touch the y-axis. Then they ask us for the domain. So domain x, all the values greater than 0. And the range y is a set of real numbers. So those are our characteristics of log 5 to the x. So it's increasing in quadrant 1 and decreasing, so increasing. So we can see this graph is really increasing in a way. Okay, so let's do one last one today. Here, question 16. You're asked to graph y log half of x. How is the graph related to the function log 2 to the x? And as I mentioned earlier, I selected values for x where I can write as the power of these. The easiest way to do this one here is to write as an exponential function. And then we switch them. What I meant by that, this could be written as y is equal to half x. And then create a table of values and interchange them. So this is my x, this is y is equal to half to the power of x. Well, what I will do, because it's an inverse of the log, so y equal to log half x is this inverse of y is equal to half to the power of x. I'll choose my x value, -3, so there's going to be half to the power 8 will give me, sorry, half to the power -3 will give me 8. And we have -2 here. If we were to write that as an exponential, that will give us, what, 4? Yes. Because half to -2 will give me 4. And I try -1, so it'll give me 2. 0, 1, 1 can give me 0.5, and 2 will be 0.25. Let's remember, all what I'm doing here, this is half to the power x here, so half to the -3 will give me, figure out this. So for example, I'll just do it on the side here to show you, so we have y is equal to half, select my -3 here. So this could give me 1/2 to the power 3, which is 1/8, which is 8. So -3 here will give me 8. Okay, so now to find the log, we interchange it. So 8, so the y here will be equal to 8. Oh, no, -3, because I'm interchanging them. This will be -2, so you give me -1, 0, 1, and 2. So that's my log to the half of x. Now log of 2 of x. We can do that easily because we become a log 2 to the power 8, which is going to give me as 2 to the power 3, which is 3. Because 8 could be written as 2 to the power 3. This is going to be 2 to the power 2. So we get log 2 to the power 2 gives me 2. Then 2 to the power 1, log 2 to the 1. Then it can be written as 1 to the power 0. And we know 1 to the powers. And that will give us so 2 to the power 0. Okay, no, it's 1 to the power 0, isn't it? It could be 0 here. And so, so we write this here, 2 to the power 0 here. We give us 0. And log 2. Now this could be written as 2 so this is equal to 1. Which is half, is 1, and this will give us log 2. So just give us 2. So plot our points. So let's plot our first one here, my graph here. So let's plot this here. We'll have x is 8, y is -3 here. Then we have x is 4, y is -2, and x is 2, y is -1, x is 1, y is 0, 0.5 is 1, and go up. Y is equal to log half x. And we plot this, we have 8, 3. So we have x is 8, y is 3. X is 4, y is 2. X is 2, y is 1. So 1, 0. We go down. Now this should be negative here. It should be negative. And 2. And this we end up with -1. So this is my graph. Down. So this is log 2 to the x. So we can conclude that if the base b is between 0 and 1, the graph is decreasing. So log, here, log half of x. So as long so this graph is decreasing, the other one is increasing. So log 2 to the x, this graph is increasing, log half x is decreasing. So notice when the base is between 0 and 1, it's decreasing. If it's greater than 1, it's increasing. So you'll want to try out questions, practice questions 3 and 4 on page 379 and lesson 4 in your booklet.